So in this video, we're going to take a look at Venn diagrams and some of the probabilities that we can extract from these Venn diagrams. So let's say that we ask a group of people whether they like athletics or basketball. Okay, and I'm going to put the results of our data from asking these people, we're going to put that into a Venn diagram. Okay, and we're going to label our circles. The one on the left here is going to be denoted by an A for athletics, and the one on the right here, a B for basketball. Okay, and let's say that we've got 6 people in here, 9 people in here, 17 people in here, and 3 people in here. Okay, and we're going to try and find some probabilities, okay, for example, what the probability of someone liking athletics is. So, to start off with, let's take a look at the probability of somebody liking athletics. So, the probability of A. And I'm going to draw in a little mini Venn diagram here, and our A and our B. Well, what section of our Venn diagram are we looking at here? Okay, well, for the probability of A, we're looking at all the things contained in A. So all the people that like athletics. So that's the entire A circle. So all of this space. And in our situation, okay, we're looking at 6 plus 9. So there are 15 people. 6 plus 9 is 15 people that like athletics. And how many people are there in total? 6 plus 9 plus 17 plus 3. Okay, we have 35 people in total that we've asked. So it's 15 out of 35. And of course, we could simplify this fraction down if we wanted to. We could divide both by 5 and we would end up with 3 over 7. Okay, to do another one, let's take a look at the probability of someone liking basketball. So this probability of B, okay, this little notation here, probability of B means what are the probability that somebody likes basketball? Well, what area are we looking at in our Venn diagram? So let's draw another Venn diagram out. And we got A and B. Well, for B, B is the entire B circle. So this circle here. Okay, and in this case, it is 9 plus 17. Okay, so that's going to give us 26. So 9 plus 17 is 26, and out of a total 35 people. So we've got a 26 out of 35 chance that somebody likes basketball. And now, is this in its simplest form? Okay, I don't think there's anything we can do to simplify that, so it would just stay as 26 out of 35. Let's do another one. Let's look at the probability now of somebody liking athletics or basketball. Okay, and what do we do when we've got this or here? Rather than writing or, we write the probability of A union B. Okay, and we have this little U symbol that sits between the two. And what does that mean? They like either basketball or athletics or both. Okay, we've just got to make sure that we get them liking at least one. So we are looking at, when we talk about the union, we are looking at anything that is inside of athletics or basketball, whether they like both, whether they just like one, as long as they like at least something, okay, we're all good. So we're looking at the probability of A union B here. So that's this entire bit inside of all of our circles. And well, what is that going to be equal to? It's going to be 6 plus 9 plus 17. Okay, so that's going to give us 32 out of 35. Okay, so we've got a 32 out of 35 chance that somebody likes at least athletics or basketball or both. And we denote that with A union B. Let's come over here and let's work out what the probability of A and B is. So now a little bit more specific. It has to be A and B. So they have to like athletics and basketball. So they've got to like both. And that is going to be our intersection between the two. So there's A up here and B over here. And where do these intersect? In this middle section here. And rather than writing A and B, we write A intersect B with that upside down U looking like that. And we're talking about this little overlap in the middle here. Oh, and I've lost it. little overlap in the middle. And what's that going to be equal to? Well, that's just equal to 9. Okay, so 9 out of 35. Okay, so we've got a 9 out of 35 chance that we've got somebody liking both athletics and basketball. Now, I'm going to put these to one side, okay, because we're running out of room a little bit. Put these to one side, and I want to do a couple more, okay? So I'm going to bring this one here over, okay, because this is going to be useful. I want to bring that one there over. And I want to take a look at what the probability of someone not liking athletics is. What's the probability someone doesn't like athletics? And we denote this by A with a little c, okay? And the C stands for complement. So we're looking at the complement of A. So what's the probability that someone doesn't like athletics? Well, we saw before, and this is why I've brought this part over, that the probability that they do like athletics is that entire A circle. So the probability that someone doesn't like athletics, okay, is going to be this bit here, everything that is not in that A circle. Oh, what's happened there? There we go. The probability that we pick somebody that doesn't like athletics is going to be that everything that's not inside of that A circle. So in this case, it is going to be, what have we got? We've got 17, okay, for this bit here. So that's going to be 17. And we've got to remember to add the people that don't like either athletics or basketball. So that 3 as well. And that gives us 20 out of 35. Now, what's really interesting about this is that if we add 20 out of 35 plus the 15 out of 35 that we found for the probability of us picking somebody that likes athletics, we end up with a whole. And that is because the probability that someone, or the probability of us pulling out somebody that doesn't like athletics is going to be everything left over from the probability of somebody that does like athletics. So we can say that the probability of A is equal to 1 minus the probability of the complement of A. Or in other words, the probability of the complement of A is 1 minus the probability of A. Okay, so let's use those to try and find the probability of somebody not liking B. So let's rub this bit out. And we're going to bring the probability of B up to the top here. So let's bring this up to there. Now, what is the probability that somebody does not like B? So B complement. Well, I could go and count them all up and draw a big Venn diagram again, but I've got these magic formulas. So instead of having to count them all up in the Venn diagram again, well, let's just say that the probability of B complement is equal to 1 minus the probability of B. It's everything left over from the people that do like basketball. Okay, so the probability of of us picking somebody that doesn't like basketball, okay, is the same as everything left over from somebody that does like basketball. So we end up with 1 minus our 26 over 35 here. And well, that is 9 out of 35. Okay, so that's the probability of us picking somebody that doesn't like basketball. Now we're going to do the same thing, and we're going to do it for the union and the intersection. And we're going to see what particular points on our map that we're looking at. So let's bring our union up. So here's our union one here. Okay. And now we're going to try and find what the probability of us picking somebody, okay, the complement of A union B. So complement. Okay, so everybody, we're trying to find everybody that doesn't like athletics or basketball or both. They're just not interested in any of it at all. Okay, and on a map, well, if we fill in the opposite of what we found for the union over here, so filling in the opposite of that, it's going to be everything on the outside, right? And that makes sense. That's the group of people that don't fit inside of our sport circle in the middle of our Venn diagram, perhaps. Okay, and well, what's the probability of this? We could read it straight off of our data set over here as 3, or we could do 1 minus 32 out of 35. from there and using our new formulas, our complement formulas down here, which is equal to 1 minus, we've just done that bit, that is equal to 3 out of 35, or the exact same as what we would have got over this side. Now finally, the very last one that we're going to do is the complement of the intersection. Okay, so let's bring our intersection up. So we'll rub this bit out. Let's bring up our intersection from over here. And now I want to look at the probability of us picking somebody, okay, that just doesn't like both of them. So we've got this group of people that do like both, okay, and I want to find out what the probability of picking somebody that doesn't like both is. So the probability of A intersect B with a complement, okay? And if we wanted to do this on the map, we would just pick everything that is not what we did over here. So can we do kind of the opposite of what we've done there? So everything that is not shaded in our one on the right. And well, that's just going to be leaving the intersection blank, which makes sense because it's everything that's not the intersection. Now we could add this up on our map over here, and we would get 6 plus 17 plus 3 for 26 out of a total 35 people. Okay, or we could do 1 minus whatever it was over here. And in this case, it was 9 out of 35. So we would end up with 26 out of 35 also. So that's pretty much it for determining some probabilities from Venn diagrams. And we've introduced this idea of complements now, okay, and some of this union intersection stuff. So plenty of practice on this on the worksheets, and there's a notes page also. Thank you.